How many of you have heard about SolarWinds 4J vulnerability? Nice. I see a lot of people having their hands raised. So these are supply chain attack. Today, we are going to talk about supply chain attack, Build Inspector, and how Build Inspector can help in mitigating supply chain attack. Hello everyone and welcome to the session. Today, myself, Anshu Kumar, Senior MTS in Security Team at VMware, having 10 plus year of industry experience with prior international experience in infrastructure team and mobile domain. I'm also a AWS certified solution architect associate and hold CompTIA Security Plus. Today, I have a co-speaker with me, Pavan. Pavan, may you introduce yourself?
Myself, Pavan Sorab. Working as a senior MTS in VMware. I have like 10 years of prior experience in developing vulnerability management tool, compliance tool, and attack surface frameworks.
Thank you, Pavan. Today, we are going to talk about taking a closer look at CI/CD pipeline logs and extracting security-related information with Build Inspector. Now, before we move on, let's talk about the agenda for the day. Today, we are going to talk about why we need to monitor build pipeline logs. What is Build Inspector? How to run and use Build Inspector? How can it work at scale? And how can we contribute to it? Why do we need to monitor build pipeline logs? And it is because of supply chain security. Supply chain is a sequence of activities, processes, entities involved in the flow of the product from the production and delivery and distribution of the product and end services from the raw material stage to the end product. It covers the entire network of organization, resources, technologies that are involved in the flow of the product. Supply chain attack is a cybersecurity attack that targets the software, hardware, and services within the flow of the product and services to gain access to the supply chain and infiltrate with malicious code, extract secrets. So the attackers, instead of targeting the intended victim, what they do is they will attack the trusted entity that is within the flow of the product in the supply chain and get access to the supply chain and have malicious code in that. So because of that, there is a challenge involved in the supply chain attack. It is very difficult to detect and defend against. So if you remember about SolarWinds attack of 2020, the attacker added a backdrop or malicious code called Sunburst to the software SolarWinds Orion. SolarWinds unknowingly distributed this to its customers, and around 18,000 customers were impacted because of it. It was after this incident that the executive order of software bill of material was issued. Talking about the log4j vulnerability. So the log4j library has a vulnerability that allows remote code execution. So the products and services that were using that particular library and the vulnerable library, they were also vulnerable. I'm sure that a lot of you, including me, would have been directly or indirectly involved in fixing the products having those library. So it is very important in a nutshell to maintain security posture throughout the software development lifecycle. And build pipeline, it falls under the same. If the attacker get access to the build environment, they can falsify and modify the test time and build time results. They can extract secret from the build environment, include malicious code in the build. So we were looking for solution to mitigate supply chain attack. And we were basically focusing on SBOM, that is software bill of material, and secure development practices. And thus, we came up with Build Inspector. So now, what actually is Build Inspector? Build Inspector is an open source project on VMware Labs in GitHub. What it does is it processes the plain text pipeline logs, which are otherwise just used for debugging when a pipeline fails. So it extracts valuable information from those logs, in even the dependencies that are present only during the build and test time. It detects and discloses potential security risk in build pipeline, like if there are any secrets, private keys that are exposed, unverified scripts that are running. It provides an additional perspective to the overall SBOM effort, and it's a proactive approach towards safeguarding the product. It is helpful for the developers as it helps them to reduce introducing risk to the supply chain. Vulnerability management team and compliance team can use the information provided by Build Inspector to identify old and vulnerable dependencies that are there in the products and services. Also, the compliance team, they need the list of software that are there in the supply chain. So Build Inspector can provide that information too. Now, talking in technical terms, what is in Build Inspector? So we created this stateless microservice and in Python, and it is designed with containerization in mind. So there are rules and extractions for it to work, and this, since it's the open source, these are community provided. What it takes is, it will take input plain text build logs. So basically, there are few API endpoints. What they will do is, they will take the input plain text pipeline build logs, and then the output will get the JSON output with the dependencies and the risk behavior. We call that findings. Or even we support for the standard bill of material format. So that we can even integrate the output of Build Inspector with other products in the market. Now, the average processing time is also less than 1 second for 16,000 line of logs. Here in the code, we are using Yara rules and Python for extraction, and we'll talk about it in the later slides. So dependency extraction. This is provided with the help of API that is /dependencies. So dependency extraction is a two-step process. In the first step, the actual extraction manager is determined, and then the extraction is done. So we get the information, the metadata, that is like what is the dependency name, the version of it, what is the extraction source, where it is downloaded from. There are already some extraction managers written in the open source like apt, yum, pip, Ruby bundle, Docker, to name some. And adding a new extraction parser is very easy, following the contribution guideline that is there in the GitHub. So let me help you with how we do the dependency extraction, or what we'll get. So if you see on the left side, these are the pipeline logs that we feed into the /dependency endpoint. And in the output, we get the list of dependencies. So if you see here, this is a dependency libnfnet link 0 with the version of AMD 64 1.0.1-3, and it is downloaded from archiveubuntu.com. So this is the code location, or the line exactly from where we got this information. It's a Linux type of package. Similarly, there are other dependencies like libLZO2-2 and so on are there, and we get the list on the right-hand side after passing it through the API. Risk behavior extraction. So this is done using the API endpoints, that is the /findings API endpoint. Here what is done is we feed the pipeline logs. If you see here on the left-hand side, we feed these pipeline logs. So here we will, after the logs parsing, it will provide us with the risky behavior, whatever is there in these logs. So this is done using the Yara. We use Yara for it. And Yara is used for basically malware analysis, but it can be customized. It's a pattern matching rule, and it can be customized according to your need. So do you see any risky behavior in the logs? Okay, I'll help you out. So if you see this line, what we are doing is we are using curl to download a script from the internet and directly passing it to bash to execute it. So this is called curl bashing. Let's say if the script that was downloaded was malicious and corrupted or compromised, and you execute it directly without verifying about its integrity, your supply chain is going to be compromised. So this findings API endpoint will find such risky behaviors along with the offset where you can find this and what was the actual finding data. Now, how to use and run Build Inspector. So it's present in GitHub, as I already told. You can clone the code and then use Python environment. You can create the Python environment so that you can install all the Python dependencies and then use UVCon server for running the microservice. We can also use Docker commands because we had already created it keeping containerization in mind. So there is already Docker file available. What you can do is you can build the image out of it and then run it and expose the container port 8080 to the local host port. So once you run the container, you will be able to see the API documentation at localhost 8080/docs, and you will have those /findings and /dependencies API endpoints there, and you can try that out. Now, Pavan will take you over the demo of Build Inspector and talk about it further.
Thank you, Anshu. So I'll be doing a quick demo about Build Inspector, how it works, and what are the API endpoints that are available there. And yeah. So as you can see, like the GitHub repository from VMware Labs. So here we have a code directory and then a description about our Build Inspector tool. So as Anshu mentioned, you can use the Docker build command, which is the easiest one, and it's exposing port 8080. So we are executing that and then making sure all the dependency required for the Build Inspector is installed and the image is created. So later we have to verify whether the image is already created. Yes, it is. And then you have to just run the Docker run command and then like the container will be created. So you can also verify it with the Docker ps command. Yes, the container is created and the port 8080 is exposed. So /docs gives us a Swagger documentation. So we can check the API endpoint with /version and then see whether the API is working as expected. And we have a parsers API which lists out all the parsers that we have integrated, currently implemented through open source contribution. So we have a rules API. Upon executing this, it will list out all the extraction rules, the findings that are already implemented there. So /dependencies API will give us all the SBOM related informations, that is the dependencies that are there in the build pipeline logs. So we have a sample build log here, which will go and paste it in the request body. Upon executing this, we will be able to actually normalize the data in the JSON format using the build inspector. And you can see we have the name, version, type, result, download location, all those things. So next is the findings API. So this uses the Yara extraction rules to find out all the risky behaviors. So we have a sample build log for this as well, where we are going to execute it through the request body. So in our sample build log, you can observe that there is a private key that is there. It is just a sample for the demo we have added. So there are two findings that it has identified. One is a warning where app does not have a stable CLI, and the other one is a RSA. So we are not extracting the whole information. We are only saying that, okay, the finding data has a private key, so which should not be done. So this is a quick demo about Build Inspector. So after we have the data as in the JSON format, so we can use it in the external tools where it can find out the vulnerabilities, threats, and then also the vulnerability scores. So how we can do it, I'll show you next. So we have like something called as OAS dependency track. So OAS dependency track is actually a component analysis platform. So it's able to extract information from the SBOM and identify the parts and the components of the software where the vulnerabilities or threats are present. It's actually a flagship project endorsed by OASP. So it is a highly recommended tool. And then it actually tracks all the components that are utilized in various hundreds of softwares that are present in the organization. So not just tracking, it also integrates with various intelligent sources of vulnerabilities. So it could be integrated with multiple vulnerability tools where the information is extracted and then is available in one single platform. So also after tracking it, it's able to identify what component which is affected and its location as well. Now we will try to understand Build Inspector and dependency track, how it can be integrated. First is we need to transform the JSON data that the Build Inspector is giving into Cyclone DX format. So Cyclone DX is a standard format for SBOM and dependency track actually expects that as Cyclone DX format. So we can leverage or use any scripts to actually convert that JSON data to Cyclone DX. So the next is, once we have the SBOM data, we can ingest that into dependency track. So after ingesting the data into the dependency track, the vulnerability is identified and then the scoring is given based on the severity. So we'll quickly show the demo of the dependency track. Here is a website of dependency track. Yeah. So like our Build Inspector, they also have a quick start thing. You can use a Docker compose command to just make those Docker containers available. So there'll be like 2 containers that will be up once you run the Docker compose command. One is a front end and the other one is an API server, both running in a different ports. So let's try to access the front end UI of dependency track here. So we have already created the credentials for it. So we are trying to logging into it. So it will give you a nice dashboard of what the portfolio of the vulnerabilities and what is the risk and all those scores. So what we'll do is we'll try to create a project. So let's call it Build Inspector pip packages. We'll be analyzing the big pip packages in the Python. So we'll create this, and once we have the data from the Build Inspector, so we can use this. We are currently writing the script for it, where it converts a Build Inspector JSON logs into a Cyclone DX. So here is a build log it's trying to analyze. First, the Build Inspector is able to convert it into a JSON format, and then later on the Cyclone DX. So the final output is pip serializer XML, which is in a Cyclone DX format. So I'll quickly jump on to the component section where I can upload this SBOM. Yeah. So after this, it will take a while to analyze all the packages that are present. One of the popular packages that you all know is the Pillow, which is used for image analysis in Python. So it has almost like 123 of vulnerabilities. So you can see what are the critical high, medium, and low that are displayed. And there are like CVEs that are already there. So basically the dependency track is verifying all these data with the National Vulnerability Database. And then it's giving the score appropriately based on that, and then saying whether what is medium and what is critical, all those things. Okay, now we showed you all the demo about like both build inspector and the dependency track. So now the automating is always a challenge. So what we recommend is an architecture which can actually scale. So here is the architecture we recommend, where we have the build inspector in the middle, and then we have the log collector service here, which is connecting to each of the CI systems. So once each of this is all like in the microservice architecture. We are using Kubernetes to leverage this. Here, each of the log collector system is service is connecting it to the CI system and then pulling all the logs. So the plain text logs is fed to build inspector, which analyzes that plain text logs and then the exported in a JSON format. Once you have the JSON format, you can always store the data for your future reference, or it can be used as an API, or have a front end itself where it will give like which pipeline has more issues or the threats in order to mitigate it. So since it is a microservice architecture, each of these services can be scaled individually. As Anshu mentioned, like earlier the build inspector was able to process like 16,000 lines per second. With this scalable architecture, it can even cross more than 1 lakh lines per second as well. So I'll quickly talk about contributing to the build inspector. So it's available in the GitHub VMware Labs build inspector. You can always fork the project, make changes to your version, ensure that all the unit tests and the functional tests are passed, and then you can raise a pull request in our build inspector repository. After that, one of the project maintainers are going to review your code, and then we follow that strictly, and then your contribution is available in build inspector. So what are the things you can contribute? The first thing that you can contribute is the extraction rules using Yara. So that's one thing. And then also a dependency manager. So we have so many dependency managers that can be integrated, so which will help in mitigating the supply chain attacks. So also, if there are any bug reports that you feel like you can fix it, since it is in Python, it's very easy to go through the code and then fix it. So we also recommend you people to fix the code as well. And also if there are any feature requests that needs to be added, so we can always take it in the GitHub issues. So here is a resource for Build Inspector. You can always scan this QR code and then access that GitHub and start contributing to Build Inspector. In summary, Build Inspector is a open source tool which is actually trying to mitigate the supply chain attacks in the future. So it is open source, and we recommend all your contribution to it. Thank you.